I'm Andy Lambrecht. I'm the Director of Marketing at RF Micron, where we're working to connect the unconnectable with a new class of sensor devices which can be deployed at price points that can be disposable in some cases. Large-scale deployment of our smart passive sensors can enable the creation of more data, of better data that can be used to create better insights and better decisions. RF Micron is based here in Austin, Texas. We were incorporated in 2006. We're profitable. We're no longer a startup. We're a growing company. We are creating smart passive sensing solutions that are based on our smart passive sensors. These sensors are wireless and battery-free and can be used to connect almost anything. The foundation of our solutions are our ultra-low power ICs, and we add additional value through our sensors, through software, and through turnkey systems. We have major Tier 1 designs and partnerships across multiple market segments. We're currently providing solutions that address the global IoT and IoE megatrends. Our sensors enable the collection of more and better data. We also have a smart hub which becomes part of the sensor network and can perform local processing before passing data off to the cloud. Sometimes critical decisions need to be made locally, especially when life and property is at stake. The global sensor market is currently estimated at $17 billion. At $2.3 billion and growing at almost 24% CAGR, the wireless sensors is the fastest growing segment within that market. The cost and complexity of the radios that are used in traditional IoT sensors require batteries, and this drives the cost up, not only in the cost of the sensor itself, but in maintenance. Price points for these devices can be $10 or more, and this limits deployment, and the size of the sensors often limits deployment as well. We're enabling increased deployment with a new class of wireless, battery-free, maintenance-free sensors. We're redefining where data can be gathered. We offer three components to this. We have our smart passive sensors, which can be deployed where other sensors cannot. These allow the collection of metadata. We have the Hermes Smart Edge development platform, which becomes part of the sensor network and can perform local processing before passing and making local decisions before passing the data off into the cloud, where further analytics can be performed. Our sensor ICs and our smart passive sensors are the foundation for our enabling these new capabilities. The Magnus IC is an ultra-low power device which consists of an energy harvesting engine, a UHF wireless communication engine, and then multiple sensing capabilities that can sense pressure, moisture, humidity, weight, and temperature, among some other things. We have new ICs in development that will expand the sensing capabilities beyond these stimuli. On the top, you can see one of our sensors, and I've got some up here that you can look at later on. This is the sensor that's shown on the top of the screen. It's similar to a Band-Aid. What the sensor is it consists of our Magnus IC, which is a tiny speck at the tip of the arrowhead here. You can't even see it. You can feel it on here, but it's very difficult to even see. So it's the IC and a printable antenna on a PET backing. This particular sensor happens to be a moisture sensor. There's an interdigitated capacitor underneath the arrowhead, the fingers that are there. This area on this particular sensor design, this area is sensitive to moisture. The capacitance will change when there's moisture present, and that changes the impedance of the antenna. And the auto-tuning front end of the IC automatically adapts to optimize communication, and the amount that it adapts is a measure of the amount of moisture that happens to be present. Okay, I see multiple questions there. So we'll start at the front of the room.
How does it harvest the energy? How does it harvest?
So we take advantage of RFID infrastructure. So an RFID reader will send out RF energy that powers up the IC. The antenna will capture the energy, and the IC will harvest it to power the IC. And then we operate off of RFID commands. But this is ultra low power. All we need is microwatts of energy to power the chip.
There's a UHF wireless communication engine that's powered by the RFID.
Yes. Okay.
How many milliamp hours do you have of storage on the chip? Is it
When the RF signal goes away, when the RF signal drops below a minimum level, the chip is no longer powered.
so when you say energy harvesting, there is no local storage?
No local storage on this device. Future devices, we may, have other capabilities.
What is the range to your hub?
The range depends on a number of issues. The range depends, on the antenna. It depends on the environment. It depends on the materials that it's placed on. So in certain extreme environments, if it's placed very close to like a body, the range might be very short, within a couple of feet. But out in open space where there's not a lot of interaction, it might be 6 to 8 meters.
Three questions. The onboard microcontroller, is that a dedicated core, or a 8-bit 8051, or a 32-bit ARM? What is it?
There's not really a microcontroller on there. There's just control logic. So it's dedicated logic.
And what is the for this moisture sensor, for instance, what is its typical cost as a Band-Aid?
So this device, in million unit quantities, we would typically price around $1.
Really? That's very impressive. And from the website, I understand the moisture device, one of the markets that it's finding its way into is medical uses, to tell when a bandage or diaper needs to be changed?
Yeah, that's something I'll get into a little bit more, but that's a different type of sensor than this one. It's actually a design where the sensitivity is on the ends of the device, and we're seeing it deployed in incontinence management so that patients can be monitored remotely.
And the RFID reader, which I call an exciter, puts out RF energy to power the device. Is that the way it works?
Yes, that's how it works.
And you said the device works on milliwatts. What is the source energy in the exciter? It's like 20 watts or something, right?
I think we operate on microwatts, but I would have to go double check on the power of the readers. Readers have a range of powers. We have small handheld readers that are lower power. There's fixed readers with high power, and there's legal limits to which those fixed readers can operate.
And do you have to use a RF Micron branded reader, or are you following a RFID universal spec so third-party readers can read your sensors?
So third-party readers can perform most of the functions with our sensors. RFID wasn't defined with sensors in mind, and there's some readers out there that don't behave well completely, and so there's some limitations as to what those do. The readers that we actually sell at the moment are based on other companies' reader modules or the readers themselves.
Two questions. How much does your RF reader cost?
Well, the lowest price demonstration kit, which consists of a reader and a number of sensors, is, I believe, $2,000 on the web.
Okay,
right?
so for a room of this size, let's say this room, let's say the floor is wet in some places. How many sensors do I need? How many readers do I need for a room of this size?
Well, to cover the room,
Yeah.
you can get a fixed reader that you can connect multiple antennas to, so you might be able to cover the room with 1 or 2 readers. And then it depends on how,
Well, how many antennas do I need then?
well, the fixed readers might support 4 antennas. And so if you had 1, that would be 4, if you had 2, that would be 8. Yes.
How many sensors can you accommodate on a single reader?
It's a very large number. The RFID technology was developed to perform inventories for,
Very
you know,
familiar with
so
the
the
industry.
technology will
For years.
support a lot of sensors. Yes.
Yeah, so out of curiosity, I'm assuming it, don't know a whole lot about RFID, assuming it behaves similar to, it's a transceiver, correct? So
Yes.
it, once powered, receives the commands, responds back appropriately to some extent, correct?
Yes.
Okay. So there isn't any danger in other surrounding RF fields that could possibly be enough to power it. It wouldn't send out false signals of, you know, some event occurring or moisture or something like that just due to a neighboring RF field.
Well, so something, it could, if something's sending out a signal within the frequency range that we operate, you know, we could potentially power,
Right.
but we'd have to receive commands in order to do anything.
Okay.
So something else is not likely to accidentally put out commands.
Right. So that's what I was just curious about. There was risk for false
Right.
readings.
Do you have a,
Sorry, go ahead.
This is true.
It looks like it's laminated, right? So like, the water isn't gonna damage it?
No, actually, so we've got various sensor designs. The water's typically not gonna damage anything. The water doesn't actually have to touch the sensor, you know, for us to detect it.
Flexible, foldable is it?
That's something that I would need to answer that, but it's pretty flexible. I mean, I don't know what the bend radius specs on that are.
Right. Would it be okay if I like literally folded it?
Possibly. I'd have to talk to the engineers more on that, but we actually do have designs. This design is a folded antenna, and I'll talk a little bit more about that one. So that's got a folded antenna so that it can be placed on metal.
Do you know what semiconductor process technology is being used for the IC?
0.18 microns.
Is it CMOS?
Yes.
Or is it?
so because it is RFID, does it support any topology? That's one question. The other thing is, does it support data streaming, and if so, what's the rate?
Well, we're compliant with the RFID standards. So, you know, we respond to the commands. You know, I'm not sure what you mean by data streaming, but RFID allows you to read sequential locations, and so we do.
So is it like, can I configure it for, let's say, so many samples per second, constant streaming of data, or is it like, you know,
Well,
when
we
it's
don't.
active, it sends the data and then that's
Yeah, you would have to perform multiple reads, so you'd have to keep giving it a read
So it's
command.
like, you know,
We wouldn't just keep streaming a sensor value, if that's what you're asking, which I think it is.
So how much is warehouse information for you?
That I don't know the exact number.
What's the thermal range on it?
So, the devices are spec'd at -40 to 85 degrees C. We can operate for short periods at higher temperatures. There's some process limits that are guaranteed to the 85 degrees.
Will they go through industrial processes like a washing machine or a dishwasher, this kind of stuff?
They ought to be able to do that. You know, a lot of that depends on the sensor design itself, you know, the adhesive and, you know, the material to design.
I see the multiple sensors in there. If I'm just interested in the location, do you have a module that is just doing the location? I don't need the temperature, the pressure, or any of those things.
Well, so the sensors are typically designed for those specific applications. So this one happens to be moisture only.
Okay.
And then there's another one here, so I think I brought another one. That is there's a temperature one that's temperature only, it doesn't support moisture. This one is a different type of moisture sensor. And the pressure sensors would be specialized antenna designs. With the exception of the temperature, on this particular device, all of the sensing capabilities are a combination of the IC and the antenna. The temperature is an on-chip circuit.
Okay. I'm looking for something like an asset tracking,
Mm-hmm.
right? Where I don't need the rest of the sensors, but just I just need to read what the location is it present or not?
So we can do the asset tracking. We can perform all the asset tracking functions that a typical RFID device does, but we might not be the most cost-effective for that because we have other capabilities, and it would be difficult to be cost competitive with the basic RFID asset tracking.
So I take it that every tag has got a unique ID.
Yes, it can.
And based on that, you can track the assets.
Yes.
But the question is, do you also have some location information?
I'm sorry, I didn't hear
Do you
that.
also have some location information? So when let's say this room is full of 50 tags or so. When I scan it, I think I get all the tags, all the information. But can I tell where tag number 21 is?
You would have to program it. When you place the tag, you would
So
there's user programmable memory
Got it.
that you could put that in.
All right. Okay.
Where do we go if we want a quantity of 10?
Our website has, right now, the lowest quantity is 100 off the website.
What's the bit depth of the sensor data?
It varies from part to part, but I think generally it's in the 8 to 12 range.
Right.
You said that there's user programmable memory on the Band-Aid itself?
Yes,
How much?
small amounts, a few words. There's a total of 512 bits on the device. And of course a lot of those are reserved for other capabilities.
That's NAND flash, so there's no power required for that.
Yeah, it's
non-volatile.
it's an MTP memory. That's I'm not sure if it's NAND flash.
Is it erasable?
Yes. Yes.
When you say senses proximity, is that proximity to other objects or proximity to, say, a daughter sensor or?
So there's a couple of different proximity sensors here that we've demonstrated. One is a proximity of the antenna to a parallel metal plate. Yeah, so you might create like a telegraph switch type device, or you create you put the back plate and the antenna with a springy material in it, and that can help. That's also how you would do pressure. There's another type of proximity which we've demonstrated, which I'll go into, and we've demonstrated in a car seat. We put the moisture tags, the moisture sensors in the back of the car seat, and that's sensing the proximity of a human body, because a human body is a bag of moisture. So that's a different type of proximity sense. Any other questions?
What's the application goal for the car seat?
So there's multiple applications for that. There's multiple reasons why you might want to do it. One is you can differentiate between people and packages, and you can differentiate between adults and children, and you can use that information to control how aggressively you deploy the airbag. You can also use it to determine, to help determine the comfort level of the person sitting in the seat, and take some action based on that.
Something something like that where it's a safety feature, would you do this with the RFID tag, or would you simply do it with something more robust with a longer life?
But we have people looking at doing this type of feature with our RFID sensors, because they can eliminate wires and that eliminates weight and translates into other things.
But in the car seat idea, you would have to have a reader in the car to utilize it, right?
Yeah, so we're working on low-cost readers, and there's, of course, a cost-benefit trade-off. But we're working on low-cost readers that could be deployed and make that an attractive solution if you're adding other things to the car as well.
How low can you go? How low can it go, the low-cost reader?
Oh, good. That's something that we have to talk offline about. So moving on here, with no need for batteries, we're redefining the paradigm here. The traditional IoT wireless sensor typically has some kind of MCU and radio, has the sensor, and has a 3-year battery. And this drives the cost up over $3 or much more depending on the capabilities that are needed. And as I mentioned, we have some of our sensors that we can deploy in large quantities for $1. This kind of deployment can vastly increase the amount of sensing capability that people can space out in their facilities, and the deployment costs are lowered and the maintenance costs are lowered. Sometimes the deployment and the maintenance costs for these sensors are much higher than the cost of the sensors themselves.
So I worked at a company right across the street here. I was doing power measurements. We were getting 5 to 6 year battery life out of these things. Indoor range is up to 50 feet. Outdoor range is up to 300 feet. We support well over 1,000 devices per reader.
Right. Yeah, and so this would have, effectively you get unlimited battery life out of it. You don't have the cost of changing the battery when they go dead. The battery allows you to get a little bit better range, and we're working on that with some future solutions also.
Did I hear we had to use specifically your reader?
No.
Okay.
We work with other readers. You get some added capabilities when you use our readers with our software. So there's some benefits to using our readers, but we have customers that are using a broad range of readers.
And that's the undisclosed price.
I'm sorry?
That's the price you're not disclosing, right?
I'm not disclosing the price of the low price readers that we haven't announced or developed yet, so that's the price that I didn't mention. We have readers and deployment systems which you can purchase off of our website right now, and the price for the demo kit was, I believe, $19.99.
It seems to me the comparison of these two models are not fair or apple to apple. The left-hand side is active because it has battery. The right-hand side is passive. And the right-hand side requires a reader to power the sensor. So meaning that if you want to do periodically monitoring environment like a moisture, then you must have the reader sitting nearby.
Right, you have to have a reader nearby, and that has to factor into what you're doing, but you also generally have something that's reading this one also. And the cost may be different, but there's overall, somebody who's deploying millions of these, that cost difference here, is gained over the sensors versus the few readers that have to be purchased. So the key to scaling this is the cost. We're leading the sensor cost curve. down to the price points that are needed to deploy massive amounts of sensors. The typical traditional IoT battery-powered sensor has IC content on those devices that exceeds $2. And our
25 to
ICs,
50 cents for like control.
well, and then there's the sensor. And you know, this is data that we've collected from some of our customers, you know, versus, you know, something that's much less than 50 cents here for this IC. So our Hermes Smart Edge platform provides edge processing capabilities. It becomes part of the sensor network. It gathers the sensor data, it can process it locally, and then it can bridge the sensor network to the cloud. This is based on an industry standard Linux processor, the BeagleBone processor module. And it has modular communications capabilities, which includes Wi-Fi, Zigbee, USB, CAN, and a couple of others, which customers can take this platform and easily scale it up in processing, down in processing, or remove communications capabilities and deploy this in multiple market segments.
So are you providing the software infrastructure for this, or is that up to the customer to provide his software infrastructure to monitor these things and figure out what he's got for inventory or temperature or whatever?
So we provide a degree of infrastructure here. We have an API on board, and then a customer needs to adapt it to their application.
So, okay.
So our Magnus IC drives a portfolio of smart passive sensors, which can sense, you know, as I've talked before, proximity and positioning, humidity, moisture, and a binary wet-dry decision, pressure and weight, and temperature, and we have the ability to provide a unique ID in the device also. And we serve multiple markets here, which I'm going to go into in a little bit more detail than what's on here. So what we're enabling is the collection of data which can be used to provide better insight and better decisions. Our sensors can be used to provide massive amounts of data. It's difficult to use that data. So in some cases, trends are important. You know, trends can indicate the health of what's being monitored. Data filtering, you know, can help identify issues. Contextual awareness is important in a lot of decisions. For example, in a motor, it's important, when a motor is at a high temperature, it's important to know whether that motor is in a restart condition, which is normal, or in an operating condition where that high temperature might be abnormal. And finally, analytics allows analysis and correlation through multiple dimensions to be able to identify issues, to identify root causes, and predict events that would be very difficult for humans to predict. So, as I mentioned, you know, we're currently being deployed in multiple markets. I'm going to go into more detail on some of these, but we're in healthcare, automotive, predictive maintenance, livestock and agriculture, construction materials, electric power, and cold chain. So a broad range of applications here.
Question on cold chain. So that's an external application, right? So who's reading who's powering your sensors in that particular case? That's.
I'm sorry?
In the case of a cold chain, that is a truck that is traveling, right?
Well, in some cases it's a truck that's traveling. There's actually different requirements at different stages of the cold chain. And the truck is, you know, there's ways that we can operate in the truck, but we need a reader there that's periodically checking, and that in today's products, that may not be the best solution. We're working on that in future ones, but at the ends, there are different needs, and we have those that we're being taken care of also.
So one more question. When you sell this thing for the temperature monitoring, how do you handle like say NIST certification and for the temperatures?
So we haven't moved into that yet.
Okay.
Have you done any testing on how many reads over the life of the sensor or can be achieved? Do they burn out eventually, or?
There should be no limit to the amount of reads. There's a limit to the amount of writes.
Okay.
So, automotive water leak detection. Automotive water leaks are a major problem with manufacturers, and to us, this is a $600 million TAM. 3% of autos make it to customers with leaks. That, combined with the high cost of repairing leaks, means that there's as much as $170 in every car in terms of leak repair costs. If you average the cost of repairing those 3% over all cars, it can be as high as $170. Every car that's manufactured goes through a rain test. You can see a picture of it over here. It's like a car wash. After that rain test, today, a worker manually checks certain locations for leaks, and small leaks will most often go undetected. We're working with multiple auto manufacturers and setting the new standard for this. We have multiple sensors that are placed in a car in different locations, and that's what this sensor is for. This sensor is based on a folded antenna design so that it could be placed on metal. The RF environment of a car is a very challenging environment, especially when the sensor is on the metal itself. So this design can be placed on metal. So we place a number of sensors, depending on the model of the car, anywhere between 6 and 12 sensors in various locations where they know are prone to the water either pooling or the water traveling, when certain leaks occur. The sensors are read before the rain test, and they're read after the rain test, and the detection of the leak, detection of the leaks is much higher percentage than the manual test. We catch a much greater percentage of the leaks. The sensor itself can detect drops of water as small as 0.2 milliliters.
Question, what does TAM stand for?
Oh, total available market.
Also, after you do the test, do you leave the sensors in there?
Yeah, they're effectively disposable in this application. They put them in there, they manufacture it, and once the car goes out the door, they're never used again. Yes?
In the long-term applications, about how long do the sensors last?
A lot of that depends on the material of the sensor itself. The sensor, depending on the materials and the adhesives, the sensor itself ought to last years.
Right.
Do they have any kind of UV protection?
They can. They don't have anything special in them right now. I mean, in this one, the IC is buried under the labels.
So the water doesn't have to touch the sensor, right?
In this case, there's areas of the sensor that are sensitive to water, and the water needs to get to the edge or very close to the edge of the sensor. Actually, 3 edges. The folded edge has no sensitivity at all to water. But there's ways to expand. There's the ways that the automakers use to expand the coverage. They, sometimes if they need to cover a broader area, they'll use a wicking tail that will wick water to the edge, and that'll cover a broader area.
Question.
Yes.
So once you install those sensors in the car, down the line, can you check those things anytime?
Yeah, you can check them at any
Meaning,
time.
the sensors are probably put in and the upholstery has been done in the car and all that?
Yes.
So they would still work?
Yes. Mm-hmm.
Yeah, that's what I was curious about. So is there any thought of incorporating a reader into the car as part of the computer onboard computer system, so you have lifetime water detection as a functionality of the car?
There's some talk about that, yes. I'm not sure that the value of that's recognized by the automakers yet. But we talk about placing readers in dealers for various reasons, so.
Well, that makes sense as well, if they're already there, right?
On the, you said like if it is a metal, the distance is like about 3 feet. Right?
Well, so these are what the way that these are typically deployed is they'll create what we refer to as a portal, and there will be a truss structure that the car will drive through, and there will be antennas around that structure, and as the car moves through it, it'll be able to read all the sensors. So it's reading everything from outside. Now the trunk is a special case because the trunk is difficult. Sometimes you can read it from the package shelf or through the back seat, but often the trunk would need to be opened. So sensors are an important part of autonomous and assisted driving. I mentioned some of this in the previously, but we have demonstrated and we've talked about various uses of our sensors beyond the water leak detection. I mentioned the seat. We've demonstrated putting moisture sensors and pressure sensors in the seat so that we can differentiate between packages and people. We can differentiate between adults and children. And in order to control the deployment of the airbag, in order to possibly change, adjust the seat if the driver or passenger is uncomfortable. We can put humidity sensors inside the cabin for climate control, for improved comfort. And we can embed sensors in the windshield to detect rain.
Does motion affect anything, the sensors, the readings or anything?
Only as it relates to other things that are around the sensors. If the sensor is moving, in free space, it ought to be able to be read. But if there's metal that starts obscuring the signal or you get different reflections, the movement can change that. So in electric power systems, we believe is a $2 billion TAM for this. Switchgear is an integral part of power distribution systems. And switchgear is prone to failure and has the potential of failing in an explosion when the maintenance worker opens the door. Some of these are cooled with oil or cooled with some other kind of flammable fluid. We can use our rugged temperature sensors. We have these, and you can come up and look at it later because I know it's hard to see, but this is an on-metal temperature sensor that's intended for use in switchgear and predictive maintenance applications. But you can use these to monitor the temperature of the individual switches in the switchgear and analyze the trends, and those trends can indicate when maintenance may need to be performed in order to prevent failure. On predictive maintenance, again, that application is for these rugged on-metal temperature sensors. But monitoring the temperature of motors is important because it can extend the life of a motor. Today's motors are designed to operate much closer to their limits than they were in the past. And so any any increases in temperature can damage the insulation and reduce the life of the motor by half. And so placing these sensors on the motor at various points and monitoring the temperature over time and analyzing those trends can allow you to determine when the motor needs to be serviced or repaired or maintained. We've recently launched a predictive maintenance system which consists of a reader, very specialized predictive maintenance software, and a number of these sensors, which can then be deployed in a facility by maintenance personnel.
Can they sense vibration at all?
No, these can't sense vibration. We've been looking at ways that we can sense vibration in the future.
There are ways to do it.
Yes.
What's the granularity of like temperature detection or something like that with a temperature sensor?
This temperature sensor, so the sensor itself, we sell with 1-point calibration. It has the capability for 2-point calibration. And for 1-point calibration right now, we're seeing plus or minus, at the calibration point, it's very close. But as you go farther away, it may be plus or minus 3 degrees. We believe that we've got ways to make that quite a bit tighter. And with 2-point calibration, it's much tighter than that.
Is that the same tolerance applied for the moisture sensing?
Yes. But on this one, in that metal environment, this one's going to have a shorter read range, typically. So, I mentioned healthcare and incontinence management. Incontinence management is, incontinence is a difficult condition that affects the quality of life of a very large percentage of patients in long-term care facilities. It affects everybody. Costs are incurred by the long-term care facility when illnesses cause patients to go back into the hospital, readmittance. There's penalties for readmittance. There's dignity issues with the patients. The patients are often combative. They might be suffering from Alzheimer's or some other condition, and they battle the caregiver, and that makes the caregiver's job more difficult. Remote monitoring of incontinence events improves all of these aspects. It reduces the cost to the facility because it reduces the illnesses that cause readmittance. It improves the dignity of the patient, and it makes the job of the caregiver easier. And what we have here is I mentioned this is a different moisture sensor, which is sensitive to moisture on the ends, and it's placed on the adult incontinence brief, and it can be read remotely from several feet, using a handheld reader, or you could put a fixed reader in the bed and be able to read from that. And then it gets tied back into the analytics of the hospital. You could do trend analysis and help monitor things that might be early indicators of some other sickness or ailment that's coming up.
Could you take a patient's temperature that way too then?
You could. It would be a skin temperature, and the accuracy of the sensor right now is probably not the right degree of accuracy. We're even in agriculture, in livestock farming. We have a customer that's places temperature sensors. They embed them under the skin of the animal, and the sensors are read whenever the animal goes to feed. Because they're always going to go to feed. That's a common point where you can just stick one reader. There are 60 billion animals slaughtered each year for food. So this is effectively a disposable application. The temperature is monitored, and the trends are analyzed, and a rise in temperature indicates, in this case a pig, that might be becoming sick. And when they can identify that, they can quickly separate it from the healthy animals, and the healthy animals finish faster. They finish 2 weeks faster when the sick ones are separated, and that lowers the cost of food and energy by 25 to 30%.
So in the use case where the pig is going out, how do you get the directional information? Do you have to put multiple readers?
I don't know exactly how they configure their readers, but I believe all they would really need is one reader above the trough, or if the trough is big, you might have multiple antennas spaced around.
The fact that that 60 billion is expected to increase 40% over the next 15 years is kind of great.
We talked with the seats about identifying like adults and children. Can you tell like how big the pig is with the water sensor?
You might be able to do that with some kind of pressure sensors, on something that it's standing on. I don't know how you would do it with something that's embedded in it. So.
How do you perform measurement of the weight?
I'm sorry.
How do you perform a measurement of the weight for the?
Well, so if you wanted to perform the measurement of a weight, you'd create a pressure sensor, and you'd basically have an antenna on the top, a metal plate on the bottom, and some kind of foam material in between that the spring constant,
Right.
The pressure constant, and you'd calculate the weight from that. So
where do you put the weight sensor on the pig?
You'd have to put it someplace where the pig is going to stand, right? And you'd probably have to have multiple sensors and do some kind of complicated calculation on that. So.
Sure. I'm sorry, just trying to understand this example with the analogy of the the animal temperature measurement. And you mentioned about the one pig is safe. Can this be applied to the actual human kids, like in a daycare or something, in a school, or the way should
I would think it could be possible. I'm not sure that the resolution of the temperature is enough. But it's enough for this, so maybe it is. So.
Right. The reason I'm asking is a lot of daycares, they have multiple kids, and if one kid is sick, they have to quarantine.
Right. And so there's other markets where we're getting traction also. Some of this has been mentioned. We have customers that are looking at using our sensors in frozen food in different parts of the food chain, and monitoring the temperature of blood bags. That's another important cold chain application. We have customers who are looking at humidity and moisture sensors to put in construction materials for the detection of leaks and for the prevention of mold. We even have a customer who's looking at creating smart bandages so they can detect bleeding within a dressed wound. So our product offering, we've got, and I'll go into this more on the next slide, but we've got sensors, we've got software, and we've got complete systems. And this might be a little hard to read the gray text from back there because it's not a lot of contrast on it up here. But we have right now we have two different ICs, two different versions of the Magnus ICs. We typically, we sell these in very limited cases. We prefer to sell sensors and systems, but there are limited cases where we sell ICs. But these ICs then are used in a range of sensors. We have the automotive water leak detection sensor. We have the healthcare, the incontinence management sensor. We have a general flexible moisture sensor, a general flexible temperature sensor, and the rugged temperature sensor, and we're working on a humidity sensor right now. You know, basically, a humidity sensor would use use a humidity sensitive polyimide material that changes capacitance based on humidity, and so that would interact with the antenna, and we'd be able to sense that capacitive change and understand the humidity as a result.
On the temperature, is it the ambient temperature or what it is touching?
It's what it's touching. You know, of course, there's going to be some temperature transfer, which is going to be slight. It's actually going to be the temperature of the circuit that's inside the IC. So as far as systems, we have demo kits, which are typically they're intended for use for evaluation of the technology. So a lot of our customer engagements start with a customer buying, the demo kit and trying out the technology. We have the Hermes IoT development platform. We have the water intrusion detection system, water intrusion detection kit, which customers use to try, to trial in their plants. We have the predictive maintenance system, which we launched earlier this year, which is a reader with specialized software, and the automotive has specialized software in it also. The predictive maintenance system has a reader with specialized software to manage the sensors on motors. We have the incontinence management system, which is used initially for trials within healthcare facilities or long-term care facilities, and we're finishing up on a switchgear specific system, which would be a little bit different from the predictive maintenance system.
On the two temperature sensors, is the rugged one just structurally tougher, or does it handle a wider range?
It's structurally tougher. It will it doesn't operate over a wider range, but the material probably for short periods of time handle higher temperatures than the flexible sensors might. It's more of a ceramic material.
What's the cost of the eval kit?
They vary. They're on the web, and so it vary. The lowest price. I moved ahead here, and I'm not sure how to move back. But the lowest price demo kit is at $19.95, and some of the predictive maintenance kits are on the order of between $4,000 and $5,000. I don't remember exactly where they are. So in summary, our wireless battery-free sensors are leading the industry and enabling the ability to sense conditions that couldn't be sensed before, or couldn't be sensed cost-effectively before. Our product is scalable. We have sensors, we have edge processing, we have turnkey systems, and we're working on higher level analytics, so that we can do some of that multidimensional analysis. And we have a unique and diversified market position addressing a TAM that exceeds $7 billion. And we have tier 1 customer traction in automotive, healthcare, and industrial applications.
Are you publicly traded?
No, we're a privately held company.
Any plans on becoming a publicly traded company?
I couldn't comment on that, so you'd have to talk to our CEO to get his ideas there, I think. So.
Who are your competitors that are second to RF Micron? You say you're the market leader in this generation of.
So there's others in the RFID space that are we right now don't look as having direct competitors in the smart battery-free wireless sensors. There are some very limited sensor capabilities out there in some other companies, but not to the degree that we have here.
The markets are somewhat different.
Yes. Mm-hmm.
Andy, I'm very impressed that your company has identified a very big niche and have become the market leaders and have identified such a huge TAM for a small privately held company. I hope you have founder stock.
Okay. Well, I appreciate that. You know, we're excited. We think that we've got a great position in the market. We see a lot of interest, and we're trying to move those, you know, beyond where they are right now, and scale the company as a result.
Yeah, and also along those same lines, you mentioned that it's an Austin company. I don't know how long you've been with the company, but could you tell us a little bit about the story of how this came to be from someone having an idea to this potentially multi-billion-dollar company?
So I've been with the company for 7 months.
Okay.
So I've not been through the evolution of the company.
Okay.
You know, I believe that the company had its origins. This is the third startup that the CEO has started.
Okay.
The company, he originated this company and started it in ATC. I can't comment on how long he was there. You know, he's grown the company along, you know, slowly, and evolved the technology as better fits, I guess, were identified. So, you know, a lot of these applications, you know, the automotive leak detection is not an application we dreamed up. You know, it's an application that an automaker saw the technology and said, we can do this. And I don't think we dreamed up the pig application.
In the healthcare space, I think like say what you guys are doing is awesome. The challenge that we have seen with a lot of these RFID based solutions is if you have things like choke points and so on, it works great, right? But when people are moving around and so on, that has been a big challenge. How do you actually address that?
Well, so a lot of these applications don't have bodies in the way. You know, bodies are a challenge. You know, I mean, you know, if you place this sensor on the body, you know, the antenna will become detuned enough that you can't read it. You know, so you know, you wouldn't be able to read through a body. You know, but a lot of these applications are industrial applications, and that's not really an issue, you know, because they're used in environments. You do have to worry about other things that are in the way. And I mean, with the automotive, you have to be careful about where you place the sensors, because you've got certain line of sight into the car from the antennas. And at some point, as the car moves through the portal, it's got to be able to, the signal's got to get there. And there's enclosed locations where you might need a tail to get into a location where an RF signal might not get. You know, if there's a hole, you know, for example, if there's a hole that's small in relation to the wavelength of the signal won't go through the hole. You know, so you might need a tail if you need to sense something in there. And so you need to understand the environment and then find ways to work around it. So,
what is the exciter or reader frequency? Is it 900 megahertz, 2.4 gigahertz?
It's in the range. So Europe and FCC are slightly different ranges. Europe, I think, is 860 megahertz, you know, plus and minus, and it's a very narrow band of frequencies. FCC is in the 900 megahertz range and a broader range of frequencies, and of course there's frequency hopping that's involved. So. Yes.
In the healthcare applications, have you done any studies, like in the cases where you're putting these sensors in very close proximity to various organs of the body? Have any studies been done about any health effects or potential health effects manipulating RF
I don't know
That
that there's been any studies that have been specific to this. You know, of course, there's all of the other, you know, studies and beliefs of how RF energy might be affecting people. So.
I think your greatest challenge here is not the sensors. I think you've got that fixed. It's actually this reader device. And so this Hermes Smart Edge device, is that the reader? Can that be battery powered? You know, how much advancement have we made there with that? You know?
That's got a reader module in it. Right now, it's a reader module of one of the reader manufacturers. And so it's basically the reference design. We will be developing, you know, lower cost readers, you know, that may be battery powered in certain applications.
So for that one now, how much power does it consume right now?
I don't know the answer to that. I mean, plugs into the wall. So.
Right. How fast can I get like a read command and data back? Like, could I measure something 100 times a second?
It would be on that order, 10 to 100 times a second, something in that order.
So you mentioned about the agriculture, right? Are these tests done in US or across the world?
I'm sorry,
The sensors for agriculture
Mhm.
and water management, are these tests done in US or across the world?
So the livestock application is done in China. And then we have some applications in North America for storage, for moisture and temperature and storage.
Do you have future design for 2.4 and 5 gigahertz energy harvesting rebroadcast at the ISM band for UHF?
That would be further out. So
Does anybody do that?
I'm not aware, but you know we've that would be something that's further out.
So how small can the whole module be?
How small can what?
Can the whole module be? So like if you want to put in a really tiny space, how small can it be?
I'm sorry, I didn't quite catch everything. Are you referring to the hole that I just mentioned?
Yeah.
So the wavelength is about a foot. So it would need to be small in relation to a foot. And I would guess that as you get smaller, you know, it would attenuate the signal to a point where you don't get enough.
What about the device itself? So like if you want to make the device as small as possible, how large should it be?
You mean the sensor?
Right.
So there you're probably asking questions that I need my antenna expert to answer. But I imagine that the antenna size, you know, relates to how much energy you're harvesting. But you know, this is a very small sensor.
I can make a guess on that. If it's operating around 900 megahertz, that's approximately 8 inches is a full wavelength. So you could operate with a full wavelength, a half wavelength, or a minimum of, excuse me, a quarter wavelength. Thus 2 inches might be the smallest antenna size.
Yeah, so I mean, you can take a look at the antenna on here, and you can see that the antenna basically, you know, is curved around. You know, so the length of the antenna is actually longer than the length of the sensor itself.
This has been very good, Andy. One last question. You're a fabless semiconductor company. Who is your fab that manufactures this?
TSMC.
TSMC. Any final questions before we conclude Andy's presentation?
Yeah, I'm interested in your reader. The question is, how smart your reader is? Meaning, I don't want to get 70 dB Fahrenheit, 70 dB Fahrenheit every 10 seconds or 20 seconds. I I want to set a threshold. Once the temperature goes beyond 45 Fahrenheit, what they need.
Yeah, so that's what some of the capabilities are, and in the predictive maintenance, you have the ability to set alarms, so that, if you go out and read, you get an alarm if you're exceeding a certain temperature.
So that's the capability of the reader.
I'm sorry?
That's the capability of the reader.
Right, well, so we actually store, in that, the reader stores the alarm values in the sensor. So,
How does the hub fit in just in a simple networking perspective? What functionalities does it provide from just network connectivity?
well, it connects Wi-Fi and Ethernet.
So is it, just from basic DHCP, static IP addressing, to offer a DNS solution?
Yes.
Can, that device, can it actually, lost the word, can it produce its own Wi-Fi that I can log onto and see a page and control it from there?
That I need to get the applications engineers that are developing that to answer that. I imagine it does. It's a standard Linux processor from TI. They're using standard Linux software.
Did you say it was a Beagle board?
Yeah, it's a BeagleBone Black.
Do you have any interest in shrinking it to smaller than 0.18?
Possibly at some time. But it would depend on, of course, depends on the need and what we're trying to accomplish.
Form factor, probably.
It's already a 0.5 millimeter by 0.5 millimeter IC.
User interface?
There's user interfaces on the readers, and there's also improvements going on user interfaces.
Browser based or?
The readers that we currently sell on the web are screens on they're mobile handheld readers. There's a screen on the Hermes, which is local, which is a graphical display.
So do you have like web APIs?
I'm sorry?
Do you have like web APIs to push data directly to cloud and third party?
We are developing APIs that will interact with certain cloud platforms. Any other questions?
Is it possible to get a copy of your presentation?
I believe so. It shouldn't be an issue. I need to make sure that there's no confidential slides beyond the last slide, so. But those can be removed. So I'd like to appreciate everybody's attention. I am greatly appreciative of the opportunity to share what we're doing here. I appreciate the questions and I'm happy to answer any more. Thank you. And I do have some brochures up here for anybody who wants them, and I brought some of the sensors. I know it's hard to see from back there to up here, so feel free to come up afterwards.
Anybody who's